Yes, sir.
Okay, so it is still visible, yes or no?
Yes, sir.
Okay, fine. Yeah. So first of all, coordination complexes, coordination compounds. Fine. So you were there na in this like chapter, right? You have done this chapter. You have the notes and all, correct?
Yes, sir.
Okay, fine. So what are complexes? What are complexes? So in complex, we have a metal atom, that is cobalt here. Okay, let Faisal join. He was not there. Assalamu alaikum, Faisal. How are you?
Walaikum salam, sir. I'm fine. How are you?
I'm good, but I need to apologize. I could not check your papers. I just saw them. I did not get any time to evaluate. So tomorrow, while you guys are giving the examination, na, so tomorrow I will evaluate those papers. Okay, Faisal?
Yes, sir.
Okay, and today we are going to learn about coordination compounds. Did you watch the lecture of coordination compounds? I think you were not there now when we read this in class. You hadn't joined that time, right, Faisal?
No, sir, I was not there at time.
Okay, fine. So pay attention. Okay, pay attention. There will be a few things that will be similar to class 11th. Okay, so pay attention and try to pick up patterns and things that you already remember. First of all, let us look at what are coordination complexes or what are coordination compounds. Okay, complexes or compounds, these are same thing. So in this, we have a central metal atom. Here we have a central metal atom that is bonded to a group of molecules or ions. For example, this molecule, it represents NH3. Okay, this represents Cl, right? So it can be attached to a group of molecules or also ions. For example, here chlorine will be attached as Cl negative, it is bonded to CO. Here NH3, here we have the lone pair of NH3 that is bonded with the cobalt metal, Okay, so these type of complexes are known as metal complex. Okay, these type of complexes are known as metal complex. Now, if they have charge, it is known as complex ion. If this whole metal complex, it has some positive or negative charge, then it will be known as complex ion. And if the compounds containing complexes, they are known as coordination compounds. Okay, so these compounds which have this type of complex, this is known as coordination compound. Okay, so and in this we have a few things that you have to remember. For example, let me give you K4 and let us have K4 Fe. Let's take CN6. Okay, so in this we have a few things. This whole part within the square bracket, that is known as coordination sphere. Okay, this whole thing is known as coordination sphere. Then the metal atom, which is inside the coordination sphere, this is known as central metal atom. Central metal atom. And this CN, it is known as the ligand. Ligand, it is bounded to, via coordinate mode, it is bonded to the central metal atom. Okay, this is ligand. Okay, then what will be K4? K4 is known as counter ion. Okay, since this coordination sphere, if it will have some charge, then that charge will be counterbalanced by this K4 ions. Okay, by this K4 ion. Is this clear, yes or no? Please tell me.
Yes, sir.
What about Faisal?
Yes, sir.
Okay, no doubt here, na? See, so there are few things that you have to remember. Counter ion, that is not very much important. Then we have central metal atom, this is important, and the ligand, that is important, and the ligand, that is important here. Okay, and this part inside the square bracket, it is known as coordination sphere, and the part that is outside, that is known as coordination number, the coordination number. Okay, now moving on. So here we have ligands, and the ligands are the molecule that is coordinating with the metal, these are known as ligands. So if they ask you what is ligand, then you'll write the molecules are ion. This is important. It can be a molecule or it can be a ion also. Coordinating to the metal are the ligands. Okay, so they are usually anions and they are polar molecules. So these are not non-polar. They're usually anions. For example, water, you can see they have delta negative here, delta negative here, delta positive here and here, right? So these are generally polar molecules or they can be anions. Okay, they can be anions. They must have a lone pair to interact with metal. So these should be electron rich, right? These will be electron rich and they will have lone pair electrons. So when they are polar, they should have lone pair electrons, and when they are charged, this charge itself signifies that it has some lone pair electrons which are not bonded anywhere, and those lone pair electrons, they can give it to the metal and form bonds and form coordinate bonds. Okay, and form coordinate bonds. Now, here let us see a few things. In this case, this was the very first observation that was made by Werner, and you can say that till that time we knew this much only. So for example, if we had COCl3 and NH3, okay, and please do remember that this part was not there. Okay, we did not know how much NH3, but there was one observation which was made by Werner, that if I have COCl3 and I add some NH3, okay, I will add some NH3 molecules, then what did he saw? He saw a violet color. Then he added a few more NH3, then he saw a green color. Then when he added a few more, he saw purple color, and then when he added a few more, he saw orange color. So he said that why is the addition of NH3? It is giving a different color to the solution. Okay. Now, if you see this part, both the molecules, they have a similar formula, but they just differ in their geometry. That is, this is trans and this is cis isomer. Okay, so these are isomers that you don't have to worry about, but what you have to see here is these things. Okay, now in all of this, you can see we have 6 NH3 molecules, 5 NH3, 4 NH3, and 4 NH3. So initially, when we had 4 NH3 molecules, we had all the 4 NH3 molecules inside the coordination sphere, and there was one chlorine that was outside. When we added more NH3, then what happened? More NH3 went inside the coordination sphere, and one Cl, it went out. Here there was Cl2, now it is one Cl inside and two Cl are outside. Now when I added more NH3, what happened? They get inside the coordination sphere, and the Cl3, it came out, and the Cl3, it came out. Okay, so that is why, due to the internal configuration of the coordination sphere, we had some changes in the color. Is that understood? Yes or no? Now in this case, you can see that here we have 3 Cl which is free. Okay, and it can ionize. So if you take CONH3, if you take CONH3 whole 6 Cl3 and you add it to water. Okay, you add into water, what you will get? You will get CONH3 whole 6. Okay, and this will be 3 positive, plus you will get 3 Cl negatives. Okay, so these are the counter ions which are free and they can dissociate. But in this part where we have the coordination sphere or the complex, this complex, it has two entities, cobalt and ammonia. This will not dissociate on addition of water. Now similarly, if I look at the case of CONH3 whole 5 Cl, then here we have the Cl atom which is inside the coordination sphere, and that is why it will not dissociate. And how many Cl atoms will dissociate? Only 2 Cl atom will dissociate. Now one thing Werner he observed was that whatever be the formula, let me clear this whole thing. Okay, so whatever be the formula, CONH3 whole 6 or CONH3 whole 5 Cl or CONH3 whole 4 Cl2, the cobalt, it is bonded with 6 ligands. Yes or no? It can be NH3 or Cl, but it is constantly bonded with 6 ligands. Okay, 6 different molecules or ions it is bonded with. Now it has a greater affinity towards NH3. That is why if I add NH3, the NH3 it replaces the chlorine, and the chlorine it goes out in the coordination sphere. Okay, it goes out in the coordination sphere. Right. Now let us. So these are the observation that he made, and let us see what were the conclusion that he got. Okay. Now Werner, he said that the metal ions, they have a primary and a secondary valency. Okay, it has a primary valency and a secondary valency. And then he said that now cobalt, since it is bonded with 6 ligand, its coordination number. Okay, this hash sign means number. Okay, so coordination number is what? It is 6. Coordination number is 6. Okay. Now next, this is one of the valency, and the one valency is, if I calculate the oxidation state of cobalt, it will be +3, and that is the secondary valency. Okay, so he said that primary valency of the metal oxidation number. So if I calculate the cobalt's oxidation, it is +3, and this is the primary valency, and the coordination number. Okay, you will see here the secondary valency is the number of atoms directly bonded to the coordination to the metal atom. So this coordination number is the secondary valency. Okay, so we have two different valency. This is the conclusion of Werner, that first is oxidation state that we all know, and now he added that there is a secondary valency, and it can be counted by counting the number of ligand attached to the metal atom. Okay, so we have two conclusions: primary valency and secondary valency from Werner's theory. Now moving on. Now this is again the same thing. The central metal atom ligands is directly bonded to make up the coordination sphere, that, as we said, that which is inside the bracket. And in COCl3, all 6 of the ligands are NH3, and 3 chlorides are outside. So this is just the observation that we were talking about. Okay. Now this is about COCl3, 5NH3. Okay, and then you will have. Then he said that there are few anions, as we discussed, and that dissociate. We discussed that also. That dissociate from complex ion when dissolved in water, and those are written outside the brackets. And Cl3, Cl2, and Cl. And these are outside the brackets, and they dissociate on adding water. Now, this is till here. Now we are going to discuss about the cis and trans, but it is not in syllabus. Okay, so the isomer part of coordination chemistry, you will see that it is not there in syllabus. So now he is going to discuss the violet and the green COCl3 4NH3. Okay, let us skip this part. Okay, now what is coordination? Coordination means, coordination bond, it is the same thing. Okay, in coordination bond, what should be there? There should be an atom that has some electron which it can give to other atom B. So A should have free electrons, right, the lone pair electrons, and B should have what? Vacant orbital. Then only we can form. Then only what we can form? We can form a coordination bond. So when an orbital from a ligand with lone pair electrons, so it should have some lone pair electrons, it overlaps with the empty orbital from the metal. So here A is our ligand and B is our metal, and ligand is giving electron to metal and forming a coordinate bond. Now, this is also known as coordinate covalent bond. Now this is a must condition, that they should have lone pair of electrons. Okay, we should have lone pair of electrons. Now, if it has lone pair of electrons, that means it is always going to be what? It is always going to be a Lewis base. Okay, it is always going to be Lewis base ligands, and the metals are going to be Lewis acids, and the metals, they are going to be Lewis acids. Bases are electron rich, acids are electron poor. Okay, remember this part. Now, the bond that is formed between ligand and the metal, they can alter most of the things. For example, they can alter the magnetic properties. Okay, they can alter the color, as we can see here. Okay, and there are other chemical properties also, which we are not going to discuss. Okay, there are other chemical properties such as ease of oxidation, ease of reduction. Okay, so those are not very much discussed. Okay, now one more thing is that metal ligand bond. So whenever metal is bonded to ligands, they will form a particular geometry. Now when I say that this metal ligand bond influences magnetic character, color, or chemical properties, I mean that these properties are influenced by the geometries that is formed by metal ligand bonds. Okay, so you have to look at the geometries. That geometries that is formed by metal and ligand bonds. Now, before moving to geometry, let us discuss some part of oxidation number. You had redox reactions in 11th standard. In that, you must have done some oxidation number, calculation of oxidation number. So if you have been given the charge on the coordination sphere, then you can calculate the charge on the metal atom. Okay, then you can calculate the charge on metal atom. And these, for example, NH3 is what? It is neutral. If I tell you Cl is there, then Cl is not, it does not exist in the universe as it is. Cl will exist either as Cl2 or it will exist as Cl negative. Okay, so whenever I'm writing Cl inside the ligand, that means it is Cl negative. Now, if I have, for example, H2O, what will be the charge of H2O? Tell me, guys. Charge on H2O?
0.
0. No, it is neutral, right? So it is neutral. So you have few items here. You can see that this whole part, it is +2 charge. And we want to calculate the oxidation state of Cu. What we can write? We can write Cu is X plus NH3 is 0. It is equal to +2. So X is equal to +2. Okay, so this is how we can calculate the oxidation state, as you have been calculating in 11th standard also, in 11th standard. Now, what else can be there? If you know the charge on metal atom, then you can also tell the charge on the whole coordination sphere. Okay, whole coordination sphere. I think that is discussed here, right? So here you can see that Cr, and this 3 in Roman numbers, it represents what? It represents the oxidation state. So chromium here, it is +3. Then we have water, which is 0. And then we have Cl, and there are 2 Cl, that is, it is -1. And this whole is equal to +1. That means if I am going to write it like this, then this will have a +1 charge. Okay, this will have a +1 charge. Okay, any doubt? Guys, any doubt till here?
No, sir.
No. Okay, now moving on. Calculate the oxidation state of metal atoms. Now, in this, I will do one of it. Okay, I will do not one. I think I have to do at least 2. Okay, I will do this one and this one, 1 and 5. Okay, so we have cobalt, which is in NH3, 6, and Cl3. Okay, and Cl, sorry, 3 will be not there. The other 3 will be here. Okay, now one thing you have to see from this whole complex, that is coordination compound, is that this Cl3 are there, right? We have 3 Cls. That means it will have 3 negative charge. Okay, so what you will do, you will write for cobalt, it is X plus NH3 will be 6 into 0, and Cl3 will be what? Plus 3 into -1, right? So what will you get?
+3.
Yes, Fatima, yes. IUPAC nomenclature, na, Fatima?
Yeah, sir.
You have to. There will be at least one question, I think, from IUPAC nomenclature coordination compounds. They usually give. Okay, so you will get X is equal to +3. Okay. Similarly, now why did I choose this first and fifth example is because here we have a counter ion, which is an anion, and here the counter ion, this is a cation. Okay, so in the fifth example, if you can see, we have K2 PdCl4. So K2 will be +1 into 2, and PD will be X plus 4 negative, and -4. This is equal to 0, right? This will be equal to 0. So now you can tell me X will be equal to, so here we have 2 plus X minus 4 is equal to 0. So X will be equal to how much? +2, na?
Yes, sir.
Yes, sir.
Okay. हाँ, we are going to discuss. ये जितने भी है ना फातिमा, ये IUPAC nomenclature वाले ही हैं. इस वजह से हमने इनको यहाँ पे कर दिया कि आप first you calculate the oxidation state, and after that you will do the IUPAC nomenclature. Okay, so you will do IUPAC nomenclature after we discuss it.
Okay,
अभी
sir.
करेंगे discuss. Okay, so you guys calculate for others. इसको ध्यान से देखिएगा, ओके। दिस वन CN, the charge on CN will be, what will be the charge on CN? Positive, negative, or neutral? Minus charge, yeah, correct. फातिमा, लास्ट क्लास में जब आप आई थी ना, एट दैट टाइम आई वेंट टू प्रे असर, ठीक है, हमने क्लास में यहाँ पे बोल के गए थे। एंड अमल्या से आपको हमने भिजवा भी दिया था क्वेश्चन पेपर। डिड यू गेट द क्वेश्चन पेपर फातिमा?
Yes, sir.
वो मेरा आप पहुंच, लेकिन फिर आप तो रुके ही नहीं, आप चली गई क्लास छोड़ के।
I think someone came home or something that day.
अच्छा, ओके। Okay, so Amalya has given answers. What would be the charge on C2O4, Amalya? What charge did you take for C2O4?
-2.
Minus, only minus. -2, na? Okay.
Yes.
So for C2O4, you can see that how can you make C2O4? We'll have 2 carbon atoms, right? And oxygens, right? Now carbon has only 3 bonds. Let us make a double bond. Okay. Now this oxygen it has single bond. That's right. It will be negative charge. This will be negative charge. So this C2O4, it has 2 negative. Okay. And this can be also sometimes written as OX. It is oxalate ion. So rather than writing K3Fe, they can also write it like this: K3Fe OX whole thrice. Okay. So these two means the same thing, oxalate ion here. If I have something like this, COOH, this is same thing, okay? So this is oxalic acid. If I remove the hydrogens from the acid, I will have COO negative, and this will be oxalate ion. Only Amalya sent me answer. What happened others guys? बाकी लोगों ने नहीं किया अभी तक.
Sir, Can you explain? I mean, can you do the last one, the sixth question?
Sixth one. Okay, आपने sixth आंसर नहीं भेजा है क्या? नहीं भेजा तो है आपने. अच्छा. So here we have the CB0 -1 and NH2CH3. इसमें doubt है आपको? Okay, sorry, Amal. Amal, you have doubt here in NH2CH3?
Yes, sir.
NH2CH3, okay, fine. So how will you make NH2CH3? Yeah, if you had NH3, it will be like this, right? And you just remove one hydrogen and you place CH3. So this is again neutral, right?
Okay.
Got it?
Yes, sir.
So this will be -1, this will be 0. This will be -1 is equal to 0. Hence you will have PT is equal to, it will be +2, I think. You wrote, okay, 0.
Sir, how NH2CH3 is 0?
NH2CH3, how it is 0? CH. Have you not seen this molecule in organic chemistry? Abir.
Yes, sir.
What is this? What is the name?
Ammonium something.
Ammonium something. What is the functional group? Functional group is amine, na?
Amine. Yes.
And then CH3.
CH3.
CH3 is meth, right?
Yeah.
CH3 is meth. Then you have, it is alkene, that is it will be methane, one amine. This is what? This is the neutral molecule, right? That is why it is 0. The charge will be 0.
Okay, sir.
So let me clear the whole screen. So the first one, we saw that this will be +3. Okay. And the second one will be how much? +3 again. I think so. We have, yeah, +3 again. And this will be again +3. This will be also +3. Here we have 3 to the 6. Yeah, +3. And how much did we find this one? K2. This
2.
is +2, na? Plus
Yeah.
2. And this is also
2.
+2. Okay. Yes, yes, Fatima. Fatima, आपने देखा नहीं क्या? अभी तुम बता रहे थे. See, you have carbon, carbon. You add 4 oxygen. Okay, so carbon will have 4 bonds. You add 4 bonds. Now oxygen, this will have minus, and this also will have minus. So this whole molecule, that is C2O4, will have 2 negative charge. Yes, Ahmed. Good afternoon. आपकी आवाज ही नहीं आई, लेकिन बहुत खराब आई आवाज. It was breaking. No, I could not hear you. Still could not hear you.
How is the last one having +2?
How is the last one +2?
Yes.
Okay. NH3 will be 0, right?
Yes.
Cl will be -1, right? NH2 CH3 will be 0. This Cl will be -1, right? So X, this will be equal to 0. Just add them all. Can you see it? X is equal to +2. Okay, fine. So now moving on. Now these are two small lines that you have to remember. Okay, and homo, hetero, the remaining part is same. Homoleptic complex, heteroleptic complex. Okay, as you can see, the complex that has same ligand. Okay, so the kind of donor atoms or the kind of donor groups, molecules, ions, if they are same, the ligands are same, then it is homoleptic, and if they are different, it is heteroleptic. Yeah? So these are very small, and it can come in 1 or 2 marks, right? You can see that 2 lines is there, so it can also come in 2 marks or 1 marks. What is the difference between homoleptic and heteroleptic? Now, please don't be such a student who goes into examination and don't even know these two simple lines. Okay, even though they are not very much related, these are just factual information, but please remember that homoleptic and heteroleptic. So homoleptic, you will have same or one kind of donor groups, and if you have more than one kind of donor group, then it will be heteroleptic. Okay. Now, moving on. Okay, fine. The coordination number, as you can see that we have already discussed, the number of groups, molecules, or ions that is attached to the metal atom, it is known as coordination number. It is known as coordination number. So coordination number, they can be, here it is 4, here it is also 4, here it is how much? 3 and 3, 6. Here also we have 3 and 3, 6. Okay. So generally you will see 4 and 6 in your class. The coordination number either will be 4 or it will be 6. Now, move on to, so that is the same thing that I was telling here. Okay, fine. Now this is something that we will get to later, but you will not get too much for square-planar and tetrahedral differences as of now. Okay. Okay, now there are a few types of ligand. We have monodentate ligands. Dentate means the number of electron pair that ligand can donate. Okay, that the ligand can donate. So if I see F negative, then it has only one negative charge. It can donate one atom. That is why it is monodentate. You can have bidentate, as we have seen, C2O4, right? So we have carbon, carbon, oxygen, oxygen negative, and double bond oxygen. So in this C2O4, it has 2 atoms which can donate. So this is bidentate. It is bidentate. Then there are some which are polydentate. So for example, this En, it is a polydentate ligand. It has many atoms, right? So it has, now En, it has 2, but if you will see EDTA, there is a second. For example, EDTA. So if you look at this whole molecule of EDTA4 negative, then what are the atoms that can donate? So it can be donated, it can donate O negatives can donate, the O negatives from here and here it can donate. So we have 4, then this lone pair of nitrogen and this lone pair of nitrogen, they can also donate, right? So we have how many donations? 6 donations. So this will be known as polydentate. Okay, this will be known as polydentate. So EDTA4. So if they ask what is the denticity of EDTA4, then you will write denticity is 6. Okay, please remember they should write EDTA4 negative. EDTA4 negative. Now you can also write EDTA. Remember EDTA as like this. You have nitrogen, and then we have another nitrogen here, and you have oxygen atoms here. So these are the 6 atoms which are donating. They can also ask some tricky questions. For example, in EDTA4 negative, how many negative charges are donating and how many neutral atoms are donating? So you have 4 negatively charged oxygen atoms and you have 2 neutral nitrogen atoms. So these will also have lone pairs. These are donating through the lone pair, and the oxygen atoms, they are donating through the lone pair via the negative charge. Okay, so we have different types of ligands. We have monodentate, we have bidentate, okay, and then we have polydentate ligands. So if the ligand can donate only one pair of electron, then it is mono. If it can donate bi, If it can donate 2, then it is bi. If it can donate more, then it is poly. Okay, so these are the examples you can see. So monodentate ligands are what? Even the water, it has the oxygen, it has 2 lone pairs, but only one of the lone pairs will be in an angle that it can give the electrons to metal atom. Okay, so please don't think that if they have 2 lone pairs, they will be having the denticity will be 2. The orientation of the lone pair, it also matters. So water and fluoride ions and all the X negative, that is halogen ions, they will donate only 1 electron. Similarly, cyanide ion, here we can see that carbon also has lone pair, nitrogen also has lone pair. Now, either of one, I mean, either the carbon or the nitrogen can donate. Both of them cannot donate. Okay. Now here OH negative, here we can see 3 lone pairs, but still the orientation should be that only one of the lone pair would be able to donate to the metal atom. Okay. Now bidentate ligand, you have ethylene diamine, that is En that you saw. Then you have seen the oxalate ion. Then there is carbonate ion in which you have CO3 2 negative, right? This is CO3 2 negative. Then this bipyridine and so these are not very much important for you guys, but please remember this short form B-pi and O-phen. Okay, so this is bipyridine and this is orthophenyltoluene. And then we have polydentate that you have seen. This one you have seen, right? Ethylene diamine, tetraacetate ion. Now these are others, diethylene, triamine, and then triphosphate. This is more important for you guys, EgTA4 negative. Okay, EgTA4 negative. Now there is one word which is known as chelating. Let me show you. If I have a metal atom and it is joined by water molecule and it is joined by water molecule like this. Okay, but I have a metal atom which is joined by, let us suppose, oxalate ion like this. Okay, so it is only coordinating with 2 ligands at a time, which is forming 2 coordinate bonds. So if I write oxygen here, and it is bonded with carbon, this is also bonded with carbon. These 2 carbons are also bonded and they have a double bond O, and it also has a double bond. Okay, so first of all, look at these 2 pictures, 1 and 2. All of you can see, yes or no? 1 and 2. Now
Yes,
the difference here that you can see between 1 and 2 is that in this the H2O are free, but this metal atom and it is bonded with oxalate and it is also forming a ring, right? It is also forming a ring after the coordination bond, after the coordinate bond, yes or no?
yes.
Can you see a ring, right? Now, when it is forming a ring, what happens? The stability increases, right? The stability increases. Now, let us suppose this H2O, this bonds break. Okay, this bond break with some heat or something. This one bond break. Okay, so if one bond will break, this water will go. I don't know where it will go. Okay, it will go away. But if I give the same amount of heat, and let us suppose that this bond break. Okay, this bonds break. This O negative, it cannot go far away because this bond is still there, right? This bond is still there. It will be in the vicinity, in the neighborhood of the metal atom, and it can attach once again. That is why what happens, the stability of chelating agents. Okay, chelating agents are generally, these are bidentate and polydentate ligands. These are chelating agents. That means they form ring. Chelate means, okay, this word chelate, it means ring. Okay, so if you have a chelating agent, that means if you have a polydentate or bidentate ligand, then what will happen? It will form a chelate. It will form a ligand. Sorry, it will form a ring, and then the stability will be higher. It will be having higher stability. Okay. I think that in the next slides we are discussing the same thing. This is biological importance that you don't have to study. These are bigger chelating agents, and these rings are again porphyrin rings. These are biological important. Have you heard of porphyrin rings in biology? No.
No, sir.
No, not wrong. Okay, fine. Okay, so this is nomenclature. Okay, let us now discuss nomenclature. Now, in nomenclature, there is a basic protocol that you have learned before also. For example, NaCl. So Na is sodium, this is chloride, right? Sodium chloride. So here we have cation, this is anion. So what is happening here? Okay, so you will, first of all, this is one thing you have to remember is that you will name the cation first, and then after that you will name the anion. Okay, so this is a general inorganic chemistry nomenclature rule that you will name the cation first, whether it is simple or it is complex. You will name the cation first, and then you will name the anion. Okay, now in coordination, what happens? It is that we name the ligands attached to the metal prefixes before the metal name, okay, before the metal name in the coordination sphere. Please remember. So let me, I think here we have example. These are the ligands and their names. We will come back to it later on, but let me here we have. So in this case, you can see this chloride ions are anion and this is cation. So we have first named the cation and then anion. Now let us look into the cation. Okay, let us look into the cation. Now in general, what we are looking at a coordination sphere. Okay, we are looking at a coordination sphere, which is a cation, Now you can see that here we have written pentaamine, then we have written chloro, and then we have written cobalt, and then we have signified, and then we have written here 3 in Roman numerals, that is representing cobalt plus 3 oxidation state. So here you can see that we are writing the ligand's name first. Okay, ligand's name first. Now, can you tell me? See, this is the amine part, right? And this is the chloro part. So while we are writing the ligand's name, we are following the alphabetical order. Okay. Now please remember this penta is not the name. Okay. Please remember penta, it is not the name. Amine is the name. Okay. So we will write the names according to alphabetical order. Penta is not a name. Penta signifies that there are 5 amines. Okay. Penta signifies that there are 5 amines. But please remember this penta, it does not have any value. Okay. So if penta was not there, let us suppose we lived in a we had a language in which there was no number, then we would have to write amine 5 times. Amine, chloro, cobalt. Okay, but we don't write amine, chloro, cobalt. Rather, we write pentaamine. So please remember this penta, it does not have any value in terms of name. It is just signifying that there are 5 amines. Please never put P, and you will see P here. Oh, P to chloro ke baad aayega, C ke baad aata hai P, hai na? P comes after C, and then you write penta. That's it. Never do that. The names of ligand. Okay, please remember the name of ligand should be in alphabetical order. Okay, should be in alphabetical order. So this is how we name. I think this naming part is clear. What you have to do is rather, this is going to be difficult because of these many ligands, and you have to remember the name. Hai na? See. For example, if you have N3 negative, then it is azido. Now, it is going to be easy for the simple ones. For example, we have bromide, chloride, cyanide, fluoride, hydroxide. Okay, so these, all of them, they will end with bromo, chloro, cyano, fluoro. All of the anionic ones, as you can see, negative ones, they end with OOO, right? And still oxide, we have oxo, oxalato. Now, ammonia, NH3, it is amine with a double M. Carbon monoxide, it is carbonate. Ethylene diamine, it is ethylene diamine. Pyridine is pyridine. Now, this water is going to be aqua. Water is aqua. Okay, so you have to keep in mind these names of ligand. That is more important. Okay, these names of ligand, that's more important. Now, let us move on to a different part here. This is the same slide. The name that end with O, and that I will come to later. Now this is a different one. Here we have the cation, counter ion, and then we have the coordination sphere as the anion. Okay. Now everything is going to be same. You can see here, we have tetrachloro, right? So chloro. Then we have oxo, because here we have oxygen, right? Here we have oxygen, and then we write molybdate. Then we write molybdate. So if we have anion, then the name, it will end with the name of metal, it will end with ATE. Okay, it will end with ATE. If it was not an anion, then we would have written molybdenum. Now, since the coordination sphere is anion, what we are writing? We are writing molybdate. It will end with in. This is the only difference. If you have the complex as anion, and if the complex is not anion, it is cation, then it is simple plain metal name. Now, then we have written the oxidation state in Roman numbers. That is it. Okay. Now you can write the coordination. First of all, you have to calculate the oxidation states. Okay, so let me write the oxidation state for you guys. You have already done that. +3. All are +3, I think, right? Except the last two. This one is +2. This one is +2. Let me tell you which one you have to do. You do the first one, you do the fourth one, and you do the fifth one. Okay, just do 3. if you want to ask me the name of a particular ligand, just ask me the name of ligand. Okay. Right now, I am more focusing on the way to write. Imagining that you have all the information. First thing is that you will have cation and anion, है ना? So you will separate these things, right? So cation, okay, one thing. आप लोग यहाँ पे confuse मत होइएगा. Even if you have MgCl2, what is the name of MgCl2? How do we pronounce it?
Magnesium chloride.
है ना? तो dichloride नहीं बोलते, ठीक है? Right? So if you have the chlorine atoms or any anion that is outside the metal sphere, outside the coordination sphere, they are simply written as chloride. Okay, you don't have to number them. This will be chloride, and the cation is CO NH3 whole 6, right? नहीं, Fatima. See, these are the cation and anion, right? And the metal sphere, ligands, and then the metal. Okay. First write the ligands and then the metal. Then also you have to, in a bracket, the oxidation state in Roman numbers, right, of the metal. सही है फैसल. Okay. हाँ, Fatima, correct, but in Roman numbers, right? Oxidation state should be in Roman numbers, that is 3. ऐसे. Otherwise, it is fine. अरे. No, Fatima. Can you please turn the mic on?
Yes, sir.
देखिए, there are a few terms, right? Cation, anion. ठीक है? तो cation क्या है यहाँ पे? This whole metal sphere is the cation and the rest is anion, right?
Mhm.
And in the cation, then we have ligand and metal. Okay, right?
Okay, sir.
Got it. So then after that, there will be anion. So in the whole, like in the bigger picture, you'll write cation and anion first. Then if you dive into cation, you have the ligands that you will write first, and then the metal, and then again the whole picture is anion will be last. Yes, Abir, correct.
So we write the ligand, then the metal, then the anion.
Then the anion. But this is not always the case. Now, this is only the case when the cation is the coordination sphere. Right? The coordination sphere is cation, right?
Okay.
First of all, divide the whole compound into 2 parts, the cation and the anion. Then identify the coordination sphere, whether it is cation or anion. Then first of all, you write the cation, and then the anion inside the cation, ligand and metal. And if it is, and if the coordination sphere is anion, then also ligand and metal. आपकी आवाज ही नहीं आ रही सही. Ahmed, what happened? Why is your voice not clear? Yes, Ahmed. Can anyone hear Ahmed properly? फैसल, आपको सुनाई थी आपके दोस्त की आवाज?
Yes, so what would be
Nahi,
the
sir.
name of
It's
cobalt?
cracking.
What will be the name of
Cobalt.
cobalt? Will be cobalt because it is cation, na? It gets 8 only if you have it in ion. It in anion.
Sir, how cobalt 3, like it is because this one is +3, so cobalt 3.
Yeah. Oxidation state like that. Yeah.
Okay, sir. Yes.
नहीं ना अहमद सी ये हम समझा रहे थे इतनी देर से नहीं ये कौन सा लिखा है इन्होंने कोबाल्ट अमोनिया नहीं पूरा ही गलत है ये तो अहमद listen here cation and then you will name the anion.
Yes, sir.
Okay, so what is the cation? It is CO NH3 whole 6, right? This is the cation. And what is the anion? Cl negative, right? Yes or no?
Yes, sir.
Now let us first of all name the cation. So coordination sphere. So whenever you are naming the coordination sphere, what will be named first? Ligand या metal? In coordination sphere, what will be named first?
Ligand. And
Ligand will be named. Ligand will be named first. So what is the ligand here? Amine, na?
Yes, sir.
And how many amines are there? 6. So this will be hexa
Yeah.
amine, and then this will be cobalt.
Cobalt chloride.
Then you will have 3 because cobalt is 3. Then you will have chloride, right? ऐसे होगा ना?
Yes, sir. Clear.
So you guys have to do first one and fourth one. अरे फोर्थ कीजिए ना भाई अहमद क्या हो गया आपको या फर्स्ट एंड देन फोर्थ
So I was supposed to do fourth.
हाँ everyone was supposed to do fourth.
Yes, sir.
हाँ फैसल गुड ट्राई अच्छा कुछ लोग तो मार देंगे नहीं ठीक है फिर से फातिमा Fatima? Fatima, are you
Yes.
there?
Yeah.
अब बताइए इसमें this and this part, right? Which is cation here?
The second one, like the bracket one.
नहीं. Whenever we write ना, please
Hmm.
remember NaCl. बताइए NaCl में कौन है cation? What is the
Na.
cation here? Na ना,
Na
right?
plus, Na plus, yeah.
ये आपको नहीं आता है क्या फातिमा? इतना देर क्यों लगा रही
Na plus, yeah.
हो? Na plus ना. So what we always write the cation first. Okay, we always write the cation first. So here K3, this potassium will be cation. So you will just write potassium. Then here we have the anion, which is a anion, and this is a coordination sphere, right? It is in the coordination sphere, and that is why you will write the ligand name first. So potassium tri-oxalato. Then we have iron. So for iron, we write ferrate, okay? Ferrate. And what is the, I think it is 3. So it will be named like this. Got it, yes or no? Tell me.
So what comes first will be the cation.
Where you are looking, there are two things. You are looking at the compound or the complex. बताइए.
Compound.
ठीक है. अच्छा, इसमें बताइए कौन सा cation है? What is the cation here?
It is anion, right?
Nothing is cation. ये Fe को metal देके cation मत बोलिएगा please. Okay, it is always central metal atom. This is ligand. Okay, there is no cation and anion inside the coordination sphere. Okay, cation and anion they exist outside the coordination sphere. Okay. Let me clear the screen.
Sir,
हाँ बोलिए.
sir, after potassium, we have to write 3.
नहीं ना, क्यों? पोटेशियम का ऑक्सीडेशन स्टेट 3 है क्या? वो तो हम देख रहे थे, कुछ लोगों ने लिखा है. पोटेशियम का ऑक्सीडेशन स्टेट तो +1 होता है ना, वो लिखना ही नहीं है. ओके, you have to just write the oxidation state of the metal inside the coordination state. Got it?
Okay, sir, yes.
Oxidation state of metal in coordination sphere. Okay, so let me just show you the answers, right? So hexamine, okay, fourth one आप लोग लिख रहे थे ना, so it will be, कहाँ गया fourth one? Potassium trioxalato ferrate 3, right? Now see, then I wrote for the fourth one, sorry, fifth one. So it will be potassium tetrachlorido palladate. This is palladium, so it will be palladate. Okay, it will be palladate. And you can see always that this is the cation name, this is the anion name, and there is a space in between. Okay, so then you will write it like this: cation. There will be some space, and there will be anion. Got it? आगे बढ़े?
Yes, sir.
Look at the names. If you have any doubt, tell me.
So sixth one.
क्या डाउट है इसमें बताइए?
How did the नाम उसने कैसे दिया?
नाम उसने कैसे दिया? अच्छा, once again we will name this one first, right? है ना? So tell me what are the ligands here? We have amine. This is chloro. And NH2CH3 is methyl amine. Right? This is methyl amine. So we have got 3 ligands, and then we have platinum. So we will write now which will come first. Amine will come first, right? How many amines are there? Because alphabetical order. We have diamine. So we have diamine. Then this is, acha, they have written chlorido. So chlorido, chloro, both are fine. Okay. Please remember, chlorido or chloro, both are fine. You can write chloro also or chlorido. Okay. I don't think, no, there will be no issue. Chloro or chlorido, both of them you can write. Now, moving on, we have methylamine. So methylamine is neutral, that is why it is methylamine. Then we have platinum. Then you write the oxidation state +2 and then chloride. Faisal, do you have any difficulty?
No sir.
किसमें दिक्कत हो रहा था?
6th में हुआ था लेकिन
आ
I
गया.
figure out.
Okay. Figure out. Okay. Chalo. Now, chalo, moving on. Now, this is one of the questions that I want to explain all of you. Explain on the basis of, so we are now discussing valence bond theory. Okay, so rather than theory, we have the question. So explain on the basis of valence bond theory that NiCN4 2 negative. हाँ बोलिए.
Isomerism is deleted, right?
हाँ मतलब deleted तो है, हमने देखा है इसमें CBSE में. आपके स्कूल में पढ़ा दिया क्या? No, no. Okay, it is deleted. I have seen in the CBSE that PDF. Okay, isomerism is deleted.
Okay.
Fine. Explain on the basis of valence bond theory that NiCN4 ion with square planar structure, okay, is diamagnetic, and NiCl4 with tetrahedral geometry is paramagnetic. Okay, it is paramagnetic. It is paramagnetic. Now, there are two things. There are few things that you can see here. You have been given NiCN4. Okay, so let me write it like this. Itna nahi likhte hain. Let me just write. You have a CN4 wala compound, okay, and then you have a Cl4 compound, right? So in which you have a Cn ligand and then you have a Cl ligand. So if you have Cn and if you have Cl, this is the only difference, right? Yes or no? Everything else is same. Here also 2 negative, here also 2 negative, here also 4 Cl, here also 4 Cl, here also Ni, here also Ni. The only thing that is different is the ligand. Here you have Cn and here you have Cl, cyanide and Cl, chloride. Yes or no? Right?
Yes sir.
This is how you approach the questions. Okay, so aapko na, like, don't look at everything, just look at the differences. Then you have been said that we have NiCl4. This is square planar. This is the information they have given, and they have also said that it is diamagnetic. Diamagnetic, right? It is diamagnetic. That means no unpaired electrons. Chlorine one is what? It is tetrahedral geometry and it is paramagnetic. Paramagnetic means there is unpaired electron. Okay, so these are the information that the questioner has given. Yes or no? Correct?
Yes.
Now let us show, explain how it is happening. Explain how it is happening. So in valence bond theory, you have to do the hybridization and then show that it is unpaired, it is not unpaired. Okay, then you have to show the hybrid orbitals, and then you will say that since these are the hybrid orbitals, what is going to happen? We are going to get a square planar. Since this is the hybrid orbital, we are going to get a tetrahedral geometry. Okay, tetrahedral geometry. Now, if you don't know, for tetrahedral, what do we need? We need sp3. Sahi hai? Yes or no? Bataiye yes or no, tell me. For tetrahedral, we need sp3, right?
Yes, sir.
Okay. What about square planar? What about square planar? So those who don't know, let me tell you. For square planar, you need dsp2. Or what you need? You need sp2d. Okay. So any of these two combination will work for square planar. So now you don't know this. Like, ये square planar का आपको नहीं पता था, but you know ना, tetrahedral is sp3, right? So when they mention tetrahedral, they assume the questioner, they assume that they have given you the hybridization also, that it is going to be sp3. Okay, so these are the information that is already given in the question. So this sp3 and dsp2 and sp2d, it is not given directly, but since they have said square planar and it is given tetrahedral, they have indirectly given the hybridization, that is dsp2 and it is sp3. Okay, now what you have to do, now you just have to show that NiCN4 is dsp2 or sp2d and NiCN4 is NiCl4, chlorine is sp3. Okay, so first of all, what you need to do is calculate the oxidation state. Okay, if you calculate the oxidation state, Cn will be 4 negative and 2 negative. This is equal to 2 negative, right? Here is x, 4 negative, it is equal to -2. So you will calculate this as x is equal to how much? +2 aa gaya. This 4 will go there, it will become +4. +4 - 2 will give you +2. Now you have calculated the Ni. Nickel is what? +2 oxidation state. So first of all, let me write the nickel atom in ground state. So in ground state, nickel will have how many d electrons? Tell me. What will be the outermost configuration for nickel? Nickel, what is the atomic number? 28. And these things you have to remember. Sakti Vikraman Fico Nicosan. Itna yaad rakhiye. Sakti Vikraman Feco Ni Zan. So 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Sakti Vikraman Feco Nicosan. Sakti Vikraman Feco Nicosan. Read this 10 times. Then you will remember this. Right? आज लगता है चैप्टर नहीं कंप्लीट हो पाएगा. We did a lot of questions, I think. 5 बजे से I have to take another class. Okay. Fine. Now we have nickel atom in the ground state. In the ground state, what do we have? We have the atomic number, or then the coordination, electronic configuration. These all things you have to remember. Okay, so this will be argon, and the outermost configuration will be 4s2 3d8. So 3d8 will be 1 2 3 1 2 3 4 5 6 7 8. Okay, so here we have paired electrons, and here we have s. Now what we need to do, we need to remove 2 electrons, because nickel +2. In nickel +2, what will happen? This 2, the outermost electron, that is 4s2 electron, they will get out. So when they will get out, you will have nickel 2+, which is having this type of configuration, okay, in which you have only the d electrons. Now you can see that. Now you can see what can happen. There are 2 possibilities. Let me show you those 2 possibilities. So in this possibility, what is happening? Nothing is happening. But in this possibility, what is happening? These electrons, these are going here. So it is pairing, right? So pairing is happening in one condition. So one condition can be without pairing. The other condition will be with pairing. So these are the 3D. This is the 4s, and this is the 4p. And here we have, so here we have 1 2 3 4. These are 3D. This is also 3D. Okay, and this is now s, right? This is the s, and this is p, and this is p. So as you can see, if we don't have pairing, we will get sp3, and if I have pairing, I will get dsp2, right? We will get dsp2. Now you tell me, when we have sp3, this is the case for what? This is the case for Cl or Cl? बताइए. Cl है ना? This is the case for NiCl4, right? NiCl4 2 negative, and dsp2, because it is square planar, it is going to be NiCn4 2 negative. And also you can see here why it is going to be. It is also having 2 unpaired electrons. That is why paramagnetic. It is having no unpaired electrons. That is why it is diamagnetic. Okay, so this is how you are going to show the how you will explain on the basis of valence bond theory that NiCn4 is having a square planar structure and it is diamagnetic. NiCl4 is having tetrahedral geometry in this paramagnetic. Now you can add one more line, and if you add this line here now, that Cl is a weak field ligand, okay, and hence what is happening, there is no pairing. But when we have Cn is a strong field ligand, that is why there is pairing happening. So these information you can write, but please remember that weak field ligand and strong field ligands, these are the concepts of crystal field theory and not of valence bond theory, okay, and not of valence bond theory. So if you don't have enough time, then you can leave this part of weak field ligand and strong field ligand if they are asking just to explain through valence bond theory. Okay, so in valence bond theory, you don't have this concept of weak field ligand, but usually people write them in answers. Okay, now you all understood how to write these type of answers? Yes or no? Tell me.
Yes, sir.
Hai okay. Now there will be some, I think, limitations of valence bond theory. So as you can see that it starts with a lot of assumptions. And it starts with the assumption that we will know the geometry, that we will know the magnetic character also. Then only we can get the idea or explain according to valence bond theory what is happening. So it is a lot of assumption. Then they will only say there is paramagnetic behavior or diamagnetic behavior. They will never give you the valence bond theory. It can never give you the exact quantitative interpretation of the magnetic data. How much is the magnetic moment? Okay, and they don't distinguish between weak and strong field ligands. Then they don't explain the color. Okay, and then they also don't explain the stabilities of thermodynamic or kinetic stability of the complexes. Now, what important points that you have to remember is that this sixth point, you remove the fifth point, and the all other points are important for you guys. Okay, so if you remove the fifth point, if you cannot remember it, don't remember it. So the sixth point, what it is saying that it cannot make exact predictions regarding the tetrahedral and square planar structures. As you can see in the previous line, that here we had to give the information about the geometry, square planar, higher, tetrahedral. So valence bond theory does not tell me whether it is square planar or tetrahedral. It can explain me why it is happening pairing or any pairing or. That's it. Otherwise, you have to give that information, either that of geometry or the magnetic moment. So if we have one of those information, then only we can say whether it is square planar or tetrahedral. Fine. So these are the points of differences, limitations points for